My name is Greg. I'm an engineer from Low-Risk, and today I'm going to take you through our OpenTitan Quickstart guide. OpenTitan is a silicon root of trust. It consists of a RISC-V core and various peripherals, such as an AES encryption engine and an HMAC block for message authentication. An example application is verifying the first code executed on boot of a machine matches a cryptographic signature and so hasn't been tampered with. It's still being developed, but as it's open source, you can get it from GitHub now and take a look. OpenTitan consists of both hardware and software components. Hardware is written in Verilog and software in C and C++. Until an OpenTitan chip is available, there's two ways you can use OpenTitan: through a hardware simulator called Verilator or by using an FPGA. We provide a release that has both the simulator binary and an FPGA image, and this quick start guide shows you how to use them. Let's have a quick look at the OpenTitan system named Earl Grey. At its centre sits the IBEX core. This is a 32-bit RISC-V embedded core, initially created by ETH Zurich and now developed by Low-Risk. It has a ROM for the boot code, flash memory for the software it runs, SRAM for the data, and a variety of peripherals, all connected via a tiled link interconnect. For further details, see the documentation. The provided pre-built release runs under Linux. I'm running this on Ubuntu 18 LTS, but Ubuntu 16 LTS and others work as well. Check the documentation for details. We need to install a few things first. My machine is already set up, but to follow the guide you will require XZ to extract the release, Screen to interact with the UART, libusb 1.x, libftdil 1.x, and USB utils. Once set up, grab the release from GitHub. Then extract it in a place of your choosing. I'm going to place it in my home directory at work/OpenTitan_builds/OT, and I will set the OT top environment variable to this path. First, let's run the OpenTitan Verilator simulation. We need to provide the simulator with two files. One is the boot ROM, the other is the software we want to run. The boot ROM is loaded into ROM and the software is loaded into flash memory. For the Verilator simulation, the boot ROM and flash contents are specified with two command line arguments. The software we have loaded is just a simple Hello World test. The simulator tells us where we can observe the UART output. /dev/pts/3 in this case. Use cat to take a look and see what's been output. Now, let's run the same thing but on an FPGA. The board we are using is the Nexus Video Arctic 7 FPGA board. It doesn't have to be run on this FPGA, but currently this is the only one we provide a pre-built image for. As well as the board, you will need a USB flash drive, as well as two micro USB cables. You can load the image onto the board with a USB flash drive to avoid having to set up the Xilinx tools on your machine. However, you do need to add a UDEV rule to ensure permissions are set correctly to access the USB devices on the board to interact with OpenTitan. To do this, you simply create a file with the path on the screen and place the lines also on the screen within it. Then reload the UDEV rules with the command shown on the screen. To program the board, you need a blank FAT32 formatted drive. Place the .bit file from the release into the root of this drive. There are two jumpers you need to set on the board. Set JP3 to USB and JP4 to USB/SD. Then insert your USB drive and switch on the board. You should see the busy LED light up, and after a short while this will turn off and the done LED lights up. The board is now programmed. Connect the first micro USB cable between your machine and the UART port. Use dmessage to find out which serial port gets assigned to the UART. In this case, it's /dev/tty USB 0. Use screen to open a serial console to the board. Then press CPU reset. You should see the boot ROM output a message. Now connect a second micro USB cable from your machine to the prog port. This is used to program the software onto the board via a small utility called SPI Flash. Let's run SPI Flash now to load our Hello World test binary. We see it output some information about the loading process and some matching info from the boot ROM. The Hello World binary now begins executing. If we type some characters into the terminal, we will see the ASCII values of these characters appear in binary on the LEDs of the board. That brings us to the end of this quick start video. If you go to the OpenTitan website, there's plenty more documentation. The Getting Started guide takes you through similar sets to the quick start, but shows you how to build the Verilator simulator, boot ROM, software and FPGA images from scratch, so you can try out your own software and RTL modifications. Thanks for watching.